Hello students, this is a JEE advanced level problem on electromagnetic induction where a conducting rod is moving on a conducting rail, a pair of two conducting rails, and a capacitor is connected on one side. So let us see how to solve the question. Let us see what is the statement of the question first of all. The question statement is like this. A wire of mass m and length L can freely slide. Basically this wire is nothing but the rod, okay, this conducting rod of mass m and length L can freely slide on a pair of parallel smooth horizontal rails placed in a vertical magnetic field B. This is the magnetic field B, which is shown by cross means it is perpendicular to the plane of this page and going inside in a vertical magnetic field. So basically this magnetic field is going inside, means vertical direction. So the rails are placed in the horizontal plane. Please understand, in this figure this rails, the rod and the capacitor, all these things in the horizontal plane. So the rod is moving in the horizontal plane, whereas this magnetic field B is perpendicular to the plane and vertically downwards. The rails are connected by a capacitor of capacitance C. The electrical resistance of the rails and the wire is 0. Okay, so everywhere resistance 0. If a constant force F acts on the wire as shown in the figure, find the acceleration of the wire. So this force is constant given the question. So let's see. Here is the diagram. So the rod is being pulled with the force F, and because of this force F, the rod will acquire some acceleration. You know, Newton's second law, acceleration is force upon mass. So an acceleration will get generated here, and because of that acceleration the rod will acquire velocity, because acceleration is rate of change of velocity. Initial velocity of the rod was 0, but now the rod will begin to move with velocity, and also this velocity should increase. Also this entire system can be replaced by an equivalent circuit like this. You know, a moving rod in a magnetic field is equivalent to a battery whose EMF is VBL. This is called motional EMF. Let us start discussion. So as the rod is pulled by a force F, the rod begins to accelerate and hence its velocity increases. Let the velocity of the rod after time t is equal to V. So now when the rod is moving with velocity V, then due to motional EMF, what happens in the rod? Due to the velocity of the rod, motional EMF will get developed in the rod, which is given by the formula E is equal to VBL. V is the velocity of rod, B is the magnetic field, L is the length of the rod. So this much amount of EMF is induced in the rod, and the upper end of the rod will be positive, higher potential, and the lower end of the rod will be at lower potential. This you can check with the right hand thumb rule. Okay, so the induced EMF in this rod is VBL, and so this rod can now be replaced with a battery of this polarity, upper end positive and lower end negative, and the battery polarity will be VBL. So now this rail rod system can be replaced with a simple battery. Let's continue further. So now since there is no resistance in the circuit, so the potential difference across the capacitor will be equal to the induced EMF. You can see in the circuit that the capacitor is connected parallel to the battery, imaginary battery, of course, it's a rod actually, but it's an imaginary battery. So what will happen, that this potential difference will generate the same potential difference across the capacitor. So if the upper end of the battery is positive terminal, so this side it will give positive charge to this plate, and the negative terminal of battery will supply negative charge to the capacitor. So capacitor will have charges plus Q and minus Q. So the charge stored in the capacitor can be written as Q is equal to CV. As you know that the formula for charge on the capacitor is Q is equal to CV, but here the voltage is written as E, and the value of E is VBL. So we can say Q is equal to C into VBL. Fine. Now from the above equation, this equation, we can see that the charge is proportional to the velocity V. We can say that as the velocity increases, charge also increases. correct? If velocity will increase, the amount of charge in the capacitor will also increase. How will the capacitor charge increase? It clearly means that a current must be flowing in the circuit, because only when this battery supplies more and more current, more and more charge will keep on depositing in the capacitor. So in this manner, you see, the battery should supply current in this manner anti-clockwise in the circuit, so that the capacitor keeps on charging. Charge Q gets increasing with time. So the current in the circuit is the rate of increase of charge in the capacitor. You know that current is defined as dq by dt. So what is Q? Q is the charge which is stored in the capacitor. So dq by dt is the rate of increase of charge on the capacitor, which is the current flowing in the circuit. So on the previous page we saw that Q is equal to CVBL. So d by dt of CVBL we do, and in this differentiation capacitance is constant, magnetic field B is constant, L is constant, take them out, and we'll have dV by dt differentiation. Now dV by dt means rate of change of velocity, which is also the acceleration of the rod, which is equal to A given here. Therefore we can replace this dV by dt and write down A. So we'll get current in the circuit as CBL into A. Next, now you note that the current that is flowing here will ultimately pass through the rod also, like this, upward direction. Current in the rod will go in the upward direction, and we know that a current carrying conductor experiences a force in the magnetic field, and this rod is actually moving in the magnetic field. You can see the rod is moving in the magnetic field, and at the same time a current is flowing in the rod like this, upward direction. So therefore definitely this rod will experience a force. So we call that force as the magnetic force FB, whose formula is ILB. This is the force which will act on the rod in the left direction. Force is equal to ILB, and the value of current is CBLA. Substitute here CBLA. We will get finally that the force is CB square L square A acting on the rod, and the direction of the force will be through the left direction. Why? To oppose the increase of the flux according to the Lenz's law. As you see, if the rod is moving rightwards due to this external force, this much area enclosed by the rod, that area also increasing as the rod moves rightwards. So the flux is increasing here. So in order to oppose the flux or to decrease the flux, the magnetic field would try to bring back the rod backwards, so it will apply a force in the leftward direction. Hence this is the total force acting on the rod, F minus FB. Now we can apply Newton's second law onto the rod. As you know, Newton's second law says net force is equal to mass into acceleration. So acceleration is rightward direction, so therefore this F must be larger than FB. So the net force is F minus FB is equal to mass into acceleration. Please note once again, the two forces are acting on the rod, but acceleration is in the rightward direction, so rightward force F must be larger than the leftward force FB. So F minus FB net force is equal to mass into acceleration. Then on the previous page we already found the formula for FB, which is CB square L square A. So substitute here. Now this term contains acceleration A, here also acceleration A, so send it to the right side. So we will get F is equal to this, and then we can take acceleration A common from both of them. We will get this expression, and now finally we can get our acceleration answer as F upon m plus CB square L square. If you note this answer, it is a constant value. This acceleration is a constant value and it does not depend on the time. It's a constant acceleration. So we know from kinematics that if the acceleration is constant, then we can use the formula V is equal to U plus AT. Once again a reminder that this formula V is equal to U plus AT can be used only when the acceleration is constant. So initial velocity of the rod was 0, so U is equal to 0. So velocity V is equal to A into T. So here is our A, just multiply it with T and we get our answer. So here is the answer for velocity as a function of time. Multiply this with T. Now we can also find out the amount of charge as a function of time. As I already said in the beginning that the charge is increasing on the capacitor. So let's see what is the charge as a function of time. Charge as a function of time can be written as charge formula was Q is equal to C into V. As you see, capacitor charge Q is equal to C into V, voltage V. Voltage is VBL. Okay, so C VBL. And just now we have found the formula for the velocity in the previous page. So from there you substitute here and you will get charge as a function of time. Then after getting charge as a function of time, we can also find current flowing in the circuit as a function of time. Current is dq by dt. Since q is a function of time, we can differentiate this and we can write current as a function of time. In fact, you can differentiate this also, dq by dt. That means if you do dq by dt, then CBL will be constant, differentiation of V would be acceleration A. So that's how we get this expression here, or otherwise you can directly differentiate this. So this bracket is a constant and this T differentiation will become 1. So this bracket quantity is nothing but the current. So in this manner we have found 4 quantities here: acceleration, velocity, charge and current. We find that current is also constant, same as acceleration. So finally we write all the 4 answers here: acceleration, velocity, charge and current, and we plot the graph also. As you can see, acceleration is constant with time, so therefore acceleration time graph is a constant, and even the current also constant, no time t here. So current as a function of time also constant, but velocity is directly proportional to time t, so graph will be a straight line, and the charge is also a function of time t, which is also a straight line. So I hope that you have understood and appreciated this video. So please press the like button, also please subscribe and share with your friends also. Thank you very much for watching my video. More videos will be coming up like this, advanced level and Olympiad level also. Please keep watching my channel. Thank you.